Hello, welcome to this video on developing IP with SYCL. In this video, you will learn how to make an IP design in SYCL, how to emulate an IP design to check for functional correctness, and how to debug your design. In this example, we are implementing the IP as a functor. Input-output interfaces should be declared as functor members. The IP implementation should be done by implementing the bracket operator. Before invoking the kernel, use the following code to select a device between an FPGA emulator, simulator, or hardware. Then create a queue object using the device. Allocate and prepare all the input and output data, and launch the kernel as a task using single task. Make sure to pass a unique identifier to the task. In this example, it's vector add ID. To emulate an IP, the FPGA device code is compiled and executed on CPU. The FPGA emulator is the fastest method to verify the functional correctness of your code. It only takes seconds to compile, unlike compiling to hardware. The performance of emulation is not representative. The FPGA emulator's timing behavior is uncorrelated to that of the physical FPGA hardware. If your code produced different result when compiled for the FPGA emulator versus FPGA hardware, your code most likely exercises undefined behaviors. You can debug your design with VS Code with some debug compilation flags. Now I'm going to demonstrate how to emulate an IP design in SYCL. Here we have the FPGA compile code sample that implement a simple vector addition kernel and a simple test bench to check the correctness. This code sample provides a C makelist file for building the design. Following CMake best practice, we will build the design in a separate folder. Now we can build the design targeting the emulator using make. On Windows platforms, we can use nmake instead. Let's run the emulation executable. Emulation is completed and the kernel behaved as expected. Let's look at an example of debugging on Windows. First, open a VS Code session where the oneAPI compiler is initialized. Then, we need to set up the C and C++ plugins with the correct C++ standard and include paths. Next, we'll be adding the debug flags in CMake. Compile the design targeting the emulator using CMake. Creating a default launch.json file and change the program to the emulation executable that we just compiled. Set breakpoint in your source code, and you can debug your design just like any other C++ program.